A company is planning to sell a new smart fitness device. Developing the product will cost $700,000 and each product will cost $30 to manufacture. Market research suggests that if they sell the device for $100, they will be able to sell 30,000 items. For each $10 they lower the price, they estimate they will sell 5,000 more. Assuming quantity demanded is linearly related to price, determine the price that will max profit. So let's look at this and take away the information that we need. First of all, we know that the cost is $700,000 to develop it, and then it's $30 to manufacture it. We know that if they sell for $100, that they could sell $30,000, and then if they lower it by $10 each, they will sell $5,000 more. So what we are going to do is determine the price to maximize profit. That's our goal. And it's also worthy to note that we are looking at a linear related situation. So in this case, let's create our linear equation and see what we can do with that. So if we know that we can sell 30,000 for $100, that gives us an XY value. Now, if we sell 5,000 more, that puts us at 35,000 sold. And we lowered the price by $10, so now we're at $90. So we're going to create our slope. So we'll do our difference in our y's over our difference in our x's. This gives me 10 over negative 5,000. So it gives me a negative 0.002. Then I'll do y minus y1 equal to mx minus x1. And I'll just use this first value here because I've already kind of used that as my x1, y1. So I have y minus 100 equal to negative 0.002, x minus 30,000. So I'll distribute. That gives me negative 0.002x plus 60 when I multiply that. And then I'll add the 100 over. So I get y equal to negative 0.002 x plus 160. So what this is my demand equation. Now, we've done a lot of math, so what's our goal? Our goal is to maximize profit. So if you consider what we know about profit, profit is equal to revenue minus cost. Why would we go about creating the demand equation? Because remember, to get your revenue or your R of Q equation, that's equal to Q times your demand equation. And so in this case, I can just call this, for continuity, this is my Q, this is my quantity. Because remember, your X's up there was how many that you could make, your 30,000, your 35,000. So we'll just take this demand equation that we just created, and we'll plug it in here, negative 0.002 Q plus 160. So I'm going to clean that up. That gives me negative 0.002 Q squared plus 160 Q. So there is my revenue function. So I'm trying to maximize profit. So I'm going to take my revenue minus my cost. So let's create that cost function. For cost function, we saw earlier that it costs $700,000 to develop and $30 per product to manufacture. So our cost function will be C of Q equal to that 700,000 plus $30 times Q each one we produce. So then we can take that and put it over here in our profit function. Now be careful when you're subtracting it. You do want to subtract both pieces. So here's my profit equation. I'm going to clean this up, so I'm going to distribute this negative throughout. This gives me negative 0.002 Q squared plus 130 Q just combining these two together, and then minus the 700,000. So if we want to find max profit, we had to create in this equation our demand function, our revenue function, our cost function, our profit function. Now, our goal is we want to maximize this. This relates into your quadratic sim. If you consider what this function looks like, the maximum value would occur right here at the vertex. So we want to find the vertex of this equation, so we'll just use our formula. Our vertex is equal to negative b over 2a, so it would be negative 130 over 2 times negative 0.002. So it gives me negative 130 over negative 0.004. And so what we'll be able to do is to find the quantity that is going to maximize that. So we'll just calculate that. And that gives me 32,500. Now, that is the quantity that will give me max profit. What we want to find is the price to maximize profit. It says determine the price. So that means at 32,500, products will be at max profit. In order to figure out the price, we're going to have to go back to our demand function. And so we would say, okay, our demand function back here at negative 0.002, we'll plug in 32,500 plus 160. And that's going to output for us our maximum, the price that will produce max profit. So we'll just multiply that using our calculator. And that gives me a value of 95. So at what price point do I need to make this smart fitness device in order for us to maximize profit? It would be at the cost of $95. So you can see lots at play here. We had to do our linear stuff, and then we landed at a quadratic. We had to be able to find that vertex in order to find the max profit. So lots at play, but I hope that helps.